All right, it's Calculus in the PM. I'm your host, Mr. Sadaka, 5.6 Related Rates, Part 2. And let's take a look. Now, these problems get a little more involved as we go on here. And, well, we'll see. We're going to need a diagram for this one here. The base of a ladder, 5-meter ladder, slides along the ground away from a building at a speed of 12 centimeters per second. At what rate is the top of the ladder coming down when the base of the ladder is 4 meters from the wall? I'm going to just pause this for a second. Okay, so we got a diagram going on here. I guess we'd call the up-down the y, just because we're familiar with the variables y and x. So here's my y distance. It's changing every second. My x distance is changing, right? What about this thing? The ladder slides along the ground away from a building at a speed of 12 centimeters per second. What would you call that as far as calculus things instead of, well, it's definitely the speed. Well, what do you guys, I'm trying not to say what it, d something, dx, yeah. dx by dy, dx over dy, I'll retry that again here. Now, it's only because I drew it this way, but my ladder is going to the left. Does it make sense for us to call it negative then? Okay. So it's negative 12 centimeters per second. If I'd drawn the mirror image, though, you would call it positive, right? It's not really, if you forgot to put the negative sign, it's not going to make a difference in this case. Yes?
Why would it be in relation to time?
Oh, so thank you. It isn't. Thank you. Because I was talking, and I forgot what the heck I was doing. Thank you very much. dx by dt. What are we looking for? The rate at the top of the ladder coming down the wall is the dy, yeah. We don't know the speed that it's falling down at. That's what we want to find. What else? Well, x and y are changing every second. We know that we're going to find it when x is equal to 4. But that 4 is not a constant, so I'll just keep it as x on the diagram, okay? And then we plug in 4 for the particular speed. What else? Do you notice this? 5-meter ladder, 12 centimeters per second. It's not cool. Is it easier to change the 12 centimeters to meters, or do you like the number better when you change the 5 meters to centimeters? If you don't want decimals in it, change the meters to centimeters, right? Everybody knows what? 100, yeah, okay. 500. So I'm going to just jot this down with here. That's 500 centimeters is actually what I'm going to use. That's important. If your units don't match, if you're given units, make sure they do. By the way, on the AP test, I haven't seen any evidence that they're going to give you, like, they're not going to test you on the metric system. You're not going to be changing units. You need units in your answers, but I've never seen a scenario where you're given centimeters and then inches for another and you got a 2.5. You're not going to be changing units or anything like that that I'm aware of. But if you did, if you're given kilometers and meters in another, I think you guys are nifty enough with your numbers that you could do that quickly. So when the base of the ladder is 4 meters from the wall, incidentally, that's when it's 400 centimeters from the wall. Okay. Actually, that's when x equals, we would call it the way we drew our diagram, negative 400, wouldn't we? Because I'm thinking of this like an axis here, right? Right? Like I said, it's only because of the way I drew it. If I drew the mirror image of this, you would get an entirely consistent answer, and you could call everything positive too. Might have been easier to draw it the other way around, but whatever. It's not that big a deal. Okay, how do we relate x, y, and 500? we need equations to work with, so we, yeah.
So we're going to use the velocity. Or do you?
Well, let's just take a look only at the triangle itself. It's a right triangle, we're assuming, eh? Yeah.
You could do the, like, find what the distance is right at the first moment, and then find what the distance is. Like, you have the negative
Yep.
12 and you have the 500, so you can find the distance of y.
Okay, the negative 12 is the speed, though.
Oh, down.
But you do have negative 400.
Yeah, and I was going to say do that after.
Okay.
You can just leave over dt the Pythagorean theorem.
Pythagorean theorem, though, is something else. Using the Pythagorean theorem, you could find the y value of that side.
Yeah.
And using the Pythagorean theorem, we could find dx by dt, or dy by dt. That's what we want as well. Okay? So Pythagorean theorem is what we're going to use to figure out a bunch of stuff. Which do you want to do first? Find the y side when x is 400, negative 400. What is y equal to? Let's do that, and then we'll get into the calculus. So the y is equal to square root. I'm going to skip the x squared plus y squared equals 500 squared. Just go right into it. 500 squared, subtract negative 400 squared. Okay. By the way, do you know this triangle? 3, 4, 5 triangle, so it's not a big surprise when you get 300 out of this, right? But if you want to, 2,500 minus 1,600 is 900, square root of 900 is 300 centimeters. Okay. Now, when you do a square root, as Tristan was just bringing up to me, you should ask yourself, is this positive or negative? The way I drew it, it's a positive 300, right? It's above. But that's exactly what that number trick comes down to, is a positive or negative, right? The one you sent me yesterday after school. Anyways, okay, we got that. And an equation, x squared plus y squared equals 500 squared. We can work with that and do calculus. With respect to time, if we differentiate, that's what we're going to do. We got what? 2x. Doesn't match, so dx by dt. 2y equals 0. Oh, dy by dt.
No.
Sorry, first I'll do this and then I'll get to your question. Sorry. I noticed my own error first. Okay, you were asking, sorry?
Y equals like the square root. There's subtraction and then a negative. Correct?
Oh, up here?
Yeah.
Negative 400,
It
negative.
should be positive. Like you should be adding the two in the next step. Not subtracting.
Ah. Or did you? Here's what I started with here. Negative 400 squared plus y squared equals 500 squared. Just going back to this, like you see, that's the
No, I
Pythagorean.
understand that now.
Okay, just double checking. Getting back to there. Okay, good. What can we do right now? We could sub in. If you want to, you can divide both sides by 2 and just make it x dx by dt, y dy by dt. But you can still sub in, right? So we can divide out the 2's. Everybody's good with that? This divided by 2, divided by 2, and divided by 2. It's still 0 there, so we're good on that. Okay, sub in. We're ready. It's done. Once you get the answer. Go ahead. I'll give you guys a chance here. Okay, I've got this going on here. The rest was algebra, right? So you get 16, negative 16. What would the unit be on this? It's the change in y over the change in t. Centimeters. Good. That's what we were measuring y in. And per second. Yeah. Okay. It's falling, so it makes sense that it's negative, right? And yeah. Do you notice, remember how I said the negative 400 was only because I drew my diagram that way? You would have gotten the same thing otherwise, even if, yeah, anyways. If you had drawn your diagram the other way, you still would have got negative 16. It would have been falling still. Now, any questions about that? It's easy when I do them. I use this ladder problem because you see variations of it a lot. And often it will actually be the ladder is falling. Now, it might be a different one. Maybe they'll give you how is the angle changing, theta or something like that. And so on. There's one in the textbook that I've assigned, I think, that has to do with the angle. I think. Anyways, more about that when you get to that. How about this? A funnel, basically, or conical drinking glass. It's filled with water at a rate of 15 centimeters cubed per second. Centimeters cubed, cc's per second. The glass is 20 centimeters tall, radius of 4. At what rate is the water level rising in the glass when the depth of the water above the vertex is 9 centimeters? Okay, I'm just scanning all the units are in centimeters, so that's good. So do you guys realize what's going on here? You're adding water into here, and as this fills up, you know, it gets this high and this high, etc. What rate? So it'll obviously rise quite fast at the start, right? Because it's less volume to fill. Then as it gets wider and wider, each second will be just a little. Okay, so we understand the problem before we even try math. That's important. Later on, we'll be trying ones where you're adding it maybe, and then it's dripping out at the bottom at a different rate. It's not that much different. But we'll start with this. Volume of a cone, do you guys remember? What's the volume of a cylinder? It's divided by 3, whatever it is. Pi r squared is the area of the base times the height. Pi r squared h is the volume of a cylinder. Take 1/3 of it for any cone or a pyramid if you're talking about boxes and stuff like that. Okay, we do need that, the volume formula, and I would give that to you. 1/3 pi r squared h. But you're going to become familiar with that after this chapter. Okay. What else? We want to get this down to talking about one variable. And since, you know, it says the depth of the water, the cone, 9 centimeters and stuff, it looks like h is the best variable to operate with. So somehow we got to replace r with an expression for h. That's my choice, anyways. You could do it the other way around, but then you got an extra step kind of at the end. How do you relate r and h, other than this formula, because that's no good to you? Think about this. Here's, think of it as a cone inside of a cone, really, the water. That's exactly it. Similar triangles. The green triangle has the same angles as the blue triangle that I put underneath, right? At any given height of water, you agree the angles are all the same? And so if you think of it that way, from the radius, the height, the relationship will always be in that. Okay. So, how do we set this up? Do you guys remember similar triangles, how to set these things up? Well, the ratio of the radius to the height, where do we actually know measurements for the radius compared to the height? The big triangle, 4 to 20. Right? Now, Like I said, we want to isolate for r so that we could sub in terms of h. 4 over 20 is a fifth. Yeah. And r in this case is equal to 1/5 of the height. So I'm going to put h over 5, okay? I'm going to sub that into my equation. So this is sort of an aside here from similar triangles. Similar triangles. So I'm going to sub that in, and now we have volume as a function of height, strictly a function of height in this case. 1/3 pi, I'll do it as 2 steps here. H over 5 squared h. So the volume function, why am I doing that? So I got h cubed on the top, and I've got pi, okay, h cubed on the denominator. 5 times 5 is 25, times 3 is 75, right? No calculus done so far, right? Now, what am I given? What's that 15 centimeters cubed? It's being filled with water at a rate 15 centimeters cubed per second. Looking at the units, can you tell me what this measurement is? Volume per second. Volume can be measured as mils. You're more familiar with that, but cc's, centimeters cubed, meters cubed, feet cubed, etc. Those are volumes as well, right? 3 dimensions. So if I find dV by dt, I have a number to put in. It did not say that this is changing. It's assumed to be a constant rate. Okay? So that's not a variable. Rate, it's a constant rate. So dV by dt, if I take this expression, differentiate it with respect to time, I've got, bring down the cube, right? So 3, I was going to reduce it right off the bat with the 75. I'll do it like this. 3 pi 75 h squared. It's a mismatch, so what do we need? dH by dt. Now, that's what we want to find too, right? Isn't it how, at what rate is the water rising? That's dH by dt, the change in height over the change in time. Okay, and it's changing every second. Now, if you want to, you can reduce 3 out of 25, or 3 out of 75 to 1 out of 25, pi out of 25. The h squared we have when the height is, what was it? When 9, yeah, okay, I've heard that. So let's just sub this in for when 9 is used. dV by dt, when you plug in h equals 9. Like I said, pi out of 25, 9 squared, so 81. What did I do that for? Okay. Anyways, I'll just finish writing down dH by dt. However, we actually have a value for dV by dt that was given. 15, right? So that's why I was saying, what am I doing here? So 15 is equal to, I'm just, now we can solve for dH by dt. Flip everything up and down, right? And it depends. If you want an exact value, that means if this was a AP non-calculator question, first of all, they'd probably have simpler numbers. They'd probably have 2s, 4s, 3s, and so on. They wouldn't, but these ones aren't even that bad to operate with anyways. You could just leave it as 15 times 25, 81 times pi equals dH by dt. Now, you could figure some more things out. I know there's a group of 3 within 15. So I'm going to multiply 15 by 25, because that's 3 times, this is 9. It's going to be 5 when I reduce that part of the fraction, right? And then you can multiply 5 times 25 quite easily. 125 over 9 pi, or 9. What did I just do?
81
Nobody stop me.
Randy, I asked.
Oh, you're just saying, well, give him a second chance.
That's what he said to me.
Did you really?
He said, I'll give him a second.
Yeah.
Why is it 9?
Yeah, okay. You should be confused. More people should be confused when I'm teaching. Okay. Anyways. So the answer, dH by dt, is equal to 125 over 27 pi. And the units would be centimeters per second, because height is a linear measurement, centimeters. Now, I don't really care what the decimal is. You can type it into your calculator if you want, but I want you guys getting used to getting answers in pies or whatever, or sometimes, 3 root 2 and stuff like that. Don't feel you have to get a decimal every time unless it's asked for specifically, right?
What, centimeters cubed per second, or is it?
Well, this is the change in the height, and the height
Oh, height.
is a linear measurement, right? So that's why I decided that it's just plain old centimeters.
Yeah.
Good question. Keep looking for those things.